Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Electrophilic aromatic substitution, nitration, rates depend on the electron density of the aromatic ring. Electron donating groups increase the rate, electron withdrawing groups decrease it. Moving on to the next step. Identify the electronic effect of each substituent on the central benzene ring. In structure, I both flanking rings contain lactone groups, C is equal to O, where the carbonyl is directly conjugated with the benzene ring, alpha, beta unsaturated lactone arrangement. This means the C is equal to O groups are in conjugation with the aromatic ring via the ring fusion, withdrawing electron density by resonance from the benzene ring. Two such strongly electron-withdrawing conjugated ester lactone groups are present. This makes the benzene ring most electron-poor. In structure, one ring has a conjugated lactone, C is equal to O directly conjugated with aromatic ring, and the other has a saturated lactone, C is equal to O not directly conjugated because a CH2 breaks conjugation. So only one strongly withdrawing group is in conjugation, the other withdraws only by induction. The benzene ring is moderately electron-poor. In structure, both flanking rings are saturated lactones where CH2 groups break direct conjugation of C is equal to O with the aromatic ring. The carbonyl groups withdraw only inductively, weakly, not by resonance conjugation. The benzene ring is least electron-poor, most electron-rich among the three. Moving on to the next step. Rank the electron density of the benzene ring. Structure, I lowest electron density, to conjugated EWG carbonyls, slowest nitration. Structure, to intermediate electron density, 1 conjugated, 1 non-conjugated EWG, intermediate rate. Structure, 3 highest electron density, both EWGs non-conjugated, only inductive withdrawal, fastest nitration. And for the final step. I to 3. A. 3 to I, incorrect, this is decreasing order. B. To 3I, incorrect, places I as fastest which contradicts its most electron-poor ring. C. I 3 to, incorrect, 3 should be faster than 2, not slower. Therefore, the correct answer is D. Therefore, the correct answer is option D.